Okay, so in this circuit, let's have a look at this collector to base bias circuit. And here we see that NPN transistor is shown, which has three pins such as collector, base, and the emitter. The voltage drop across base and emitter is called as VBE. The voltage drop across collector and emitter is called as VCE. The emitter is grounded, and you have a supply voltage VCC and a resistor called RC, that is a resistor in the collector branch, is connected and to the one end of the VCC, and other end of the RC you have another connection that goes to the base through the resistor RB. So let's understand how this circuit works by calculating and deriving an expressions for various voltages and the currents, and let us see if and how this circuit is robust against the DC operating point that is set by the resistors RB and RC. So the name of the circuit is called as collector to base bias. It employs a negative feedback, we'll see in a moment how, to prevent the thermal runaway, and therefore it helps to stabilize the operating point. So thermal runaway in a transistor circuit is a condition where temperature of the circuit suddenly rises so that there is a large amount of collector current that flows through the body of a transistor, which can damage the transistor. Similarly, when we talk about the DC operating point, it is the Q point or quiescent point, or also called as bias point or an operating point, around which the circuit functions as an amplifier or some other signal processing circuit. So DC operating point specifies the DC current and the DC voltage